Morning, students. Myself, Vijay Shankar from PC Department, Chevrolet Engineering College. So today we are going to discuss about the few more examples in the inverse transformation. So yesterday we discussed about some examples in residue form, residue method, or it is a counter integration method. So the given x of n is equal to the sum of zi minus z minus zi x of z into z power n minus 1 where z is equal to zi. Okay. See, this example is already discussed in the previous class. Even I'm explaining it once again. For a given x of z, evaluate x of n for which counter integration method or the residue method. The given function is x of z is equal to z by z minus 1 whole cube. Z by z minus 1 whole cube. Where the pole is 1 because z is minus 1 is equal to 0. Z minus 1 is equal to 0. The z is equal to 1. That is a pole. And here the power is there. That power value is cube means the poles whatever we have get at the 3 times. The pole is a 1 and it will get the 3 times because of it having the cube. So therefore the zi is equal to 1 and the k is equal to 3. Zi is equal to 1 and k is equal to 3. So to get x of n by using the residue method, you have to use one of the formula is there here. 1 by k minus 1 factorial, where k is the order here. Dou power k minus 1 by dou z k power minus 1, z minus zi whole power k, x of z, z power n minus 1, where the z is equal to zi. Okay. And here, because of the k is equal to 3, you will get the dou square by dou z square, and z minus zi is a 1, whole power k. Whole power k means is a 3. We'll get the 3, and the x of z having the z by z minus 1 whole power cube is there. So both are get cancelled, z power n minus 1. Got it, by the students. So now we can substitute here, see. The k value is a 3, k is equal to 3, 1 by 3 minus 1 factorial, and dou power 3 minus 1 by dou z 3 minus 1, z minus 1 whole square, z minus 1 whole cube, not the square, here it is, my students, this is a cube, z minus 1 whole cube because the k is equal to 3. What is the x of z? Z by z minus 1 whole cube, and is multiplied with the z power n minus 1, where at, not the where, at z is equal to 1. So z minus 1 whole cube and z minus 1 whole cube is get cancelled here. And 1 by 3 minus 1 is a 1 by 2 factorial, and dou power 3 minus 1 is a dou square by dou z square, and z power n, z power minus 1. So z and the z power minus 1, bases are the same, power can add, it becomes the z power 0. Anything power 0 value is a 1. So we have remaining only the z power n. Apply the second derivative for the z. The first derivative is n into z power n minus 1, and the second derivative is n already we have, and z power n minus 1 differentiation of the partial differentiation is n minus 1 z power n minus 2 at the z is equal to 1. Substituting the z is equal to 1, the term z power n minus 1 n minus 2 becomes a 1, and 1 by 2 n into n minus 1, where it is greater than the 0. N is greater than the 0. When n is less than the 0, the value is a 0. Since the magnitude they are asking here is a greater than 1. Okay. You can multiply the x of n is equal to 1 by 2 n into n minus 1 mu of n. N into n minus 1 mu of n. Okay. For the given z by z minus 1 whole cube, the inverse transformation x of n is 1 by 2 n into n minus 1 mu of n. Got it, my students? Similarly, you can take another example. 3z inverse by 1 minus 1 by 2 z inverse whole square. These also we already discussed in the last class, but once again I am explaining the 3z inverse by 1 by 1 minus 1 by 2 z inverse whole square. So what is the power here? The 2. First of all, the given negative powers of z is converted into the positive powers of z. So 3z inverse means 3 by z, and here 1 minus 1 by 2 z whole square, and take the LCM here, 3 by z whole divided by, I'm taking only the z, only if I am taking the z minus 1 by 2 whole divided by z whole square. So taking the LCM, only the z I am taking, z minus 1 by 2 by the z whole square. So here there is a z is there in the denominator, and here it is a z square is there in the denominator. Okay, 3 by z whole divided by, I'm taking the z minus 1 by 2 whole square, and here the denominator is also the z square. So z and this square will get cancelled. It becomes of 3z whole divided by z minus 1 by 2 whole square. And this x of z is given. After converting the positive powers of z, now x of z is converted to the x of z by z equation. X of z by z is equal to 3 by z minus 1 by 2 whole square. Okay. If it is a multiple powers, multiple poles is there, no need of taking the x of z by z. You can keep that as a 3z by z minus 1 by 2 whole square only. Otherwise, you can write this as a by z minus 1 by 2, b by z minus 1 by 2 whole square. What it matters, students? Whole square. You can find out the a value and the b value, and continue to find the values as a. You see the a by the z minus 1 by 2 actually, plus b by z minus 1 by 2 whole square. What it matters, students? When we can find this x of z by z function, x of z by z function. Now I got this, I'm removing all these ones. This x of z by z is equal to x of z by z is equal to a by z minus 1 by 2 plus b by z minus 1 by 2 whole square. So this is a way, it's a partial fraction expansion method. Again, you can find out the a value and the b value. You can go for it's a partial fraction expansion method, you get directly. But here they're asking find the inverse transformation by using the residue method. So what is the x of z now? The 3z by z minus 1 whole square. In this, what is the k value? K is equal to 2. And z minus 1 by 2 is equal to 0. The value is 1 by 2. The pole is 1 by 2. And it appears at the 2 times. So x of n is equal to dou by dou z of k minus 1 means 2 minus 1. It is a 1 only. Z minus 1 by 2 whole square, 3z by z minus 1 whole square, and z power n minus 1, where z is equal to 1 by 2. So z minus 1 by 2 whole square and z minus 1 by 2 whole square get cancelled. 3z is z power n minus 1. In this, z power 1 and z power minus 1 get cancelled. We have only the z power n. One time only can apply the partial differentiation for the z power n. 3n z power n minus minus 1, where z is equal to 1 by 2. And the x of n is equal to 3n 1 by 2 whole power n minus 1 mu of n. Therefore, the x of n is equal to 3n 1 by 2 whole power n minus 1 mu of n. Why I am taking it the mu of n? Because the magnitude of z is greater than 1 by 4 is given. So you can multiply this function with mu of n. Mu of n. And coming to this, it is a very important function. Z by the previous two examples, we have only the one pole and it gets in the 2 times or the 3 times. But here the 2 poles we have, one pole will get the 2 times and another pole will get the 3 times. Okay, what is the one pole here? The z plus 1 is given. Z plus 1 is equal to 0. So z is equal to minus 1. Minus 1 is a pole. And z plus 2 is equal to 0. Z is equal to minus 2. Z is equal to minus 2. Z is equal to minus 1 will get it the 2 times because it having the power 2. And Z is equal to minus 2 with the 3 times it appears because it powers is a 3. And they're asking how to find out when the Z is greater than the 2 towards the right side, Z is less than towards the left side, and in between the 1 and 2 also you have to find out giving the ROC. With the ROC of Z is greater than, Z is less than, and in between of 1 and 2, have to find out the given x of Z inverse Z transformation x of n. Got it, my dear friends? So using this one Z is equal to minus 1 2 times and Z is equal to minus 2 3 times by using the residue method. What is the residue method formula? 1 by k minus 1 factorial dou power k minus 1 dou z power k minus 1 whole multiply with z minus zi, that is zi is a poles, whole power k and x of z multiplying with z power n minus 1 at z is equal to zi. Using this relation, you have to find out the residue method for the given x of z to find the x of it. So first if we have minus 1 with the 2 times and minus 2 with the 3 times means 2 residue methods will get z plus 1 whole square and z plus 2 whole cube. The first part if I am taking, the first part k minus 1, k value is there for the first part, k is equal to 2. K is equal to 2 and zi is equal to 1, not the 1 minus 1. In this, k can substitute k minus 1 is a 2 minus 1 factorial and k dou power 2 minus 1 dou z 2 minus 1 means the value is dou by dou z. And z minus zi is a minus 1. So z plus 1 whole square, z by z plus 1 whole square and z plus 2 whole cube, z power n minus 1 at z is equal to minus 1. So because it is a first derivative only, after cancelling the z plus 1 and the z plus 1 whole square, we have z power n, z plus 2 whole power cube. Now it is in the form of u by v rule. U by v rule. Take the v first of all, z plus 2 whole cube, and apply the derivative for the u, n into z power n minus 1 minus u into derivative of v, that is a 3 into z plus 2 whole power 3 minus 1. That is students, so 3 minus 1 here is nothing but the 3 square, not the 3 square, z plus 2 whole square. Got it? So I am taking here dou by dou z of z power n whole divided by z plus 2 whole cube. Okay. Now I am taking the first of all, it is a v z plus 2 whole cube and derivative of u n into z power n minus 1 minus taking the u z power n, apply the derivative of this one, 3 into z plus 2 whole power square whole divided by z plus 2 whole cube square. V square will get. Square means it is nothing but the 6. At z is equal to minus 1. Got it, my dear students? Z is equal to minus 1. Now we can apply the minus 1 here. Apply the minus 1. So 2 minus 1 is a 1 cube. N into minus 1 whole power n minus 1 minus minus 1 whole power n, 3 into minus 1 plus 2, nothing but is a 1 square whole divided by minus 1 plus 2, that is a 1 whole power 6. What is the remaining here? N into minus 1 whole power n minus 1 minus minus 1 whole power n into 3. 1 power 6, anything is a 1 only. Got it, my dear students? Now we can rewrite this n into minus 1 whole power n and minus 1 whole power minus 1. Okay, bases are same, we can add the powers here. Minus 1 whole power n into 3. Got it, my dear students? So minus 1 whole power minus 1 is becomes of minus only. Got it? Both the functions is a minus, that is equal to minus n into minus 1 whole power n minus minus 1 whole power n into 3. Take the minus 1 whole power n and the minus is a common. Minus n plus 3 minus 1 whole power n. Okay, that will get as a x1 of n because it is the first part. Part 1, we did the part 1 when the zi is equal to minus 1 and the k, it is a 2 times. So x1 of n is equal to, we got a minus of n plus 3 minus 1 whole power n. Let it be the equation 1. Now I am taking the second part using the residue method. What is the second part here? Z plus 2 whole cube and 2 into. See, using this formula here, minus 2 will get in the 3 times. Minus 2 will get in the 3 times. Okay. 3 times means now I can take this dou, not the dou, 1 by k minus 1. What is the k here? The 3. 3 minus 1 factorial and the dou 3 minus 1 by dou z 3 minus 1 will multiply with what is a z minus zi? Z minus zi is a z plus 2 whole power cube x of z. What is the x of z? Z by z plus 1 whole square and z plus 1, z plus 3, not the 3, z plus 2 whole cube, and it is multiplied with the z power n minus 1 at z is equal to minus 2. Okay, using this formula, by using the residue method, you can find out the x of n for the second part, x2 of n. 1 by 3 minus 1 means 1 by 2 factorial. And dou square by dou z square. And here z plus 2 whole cube and z plus 2 whole cube get cancelled. And the z and minus 1 is also get cancelled. Okay. And we have only the z power n by z plus 1 whole square at z is equal to minus 2. Got it, my dear students? Now you can apply this as 2 times partial differentiation. 1 by 2 factorial is nothing but the 1 by 2. I'm taking here u by v rule, dou by dou z of dou by dou z of again. Take the first one is a z plus 1 whole square and apply the derivative for this one u n into z power n minus 1 minus taking the v z power n u and 2 into z plus 1 whole power 1 whole divided by z plus 1 whole square, it becomes of z plus 1 whole power 4. Got it, my dear students? At z is equal to minus 2. At z is equal to minus 2. And again, you can simplify here. Inside it is a simplified 1 by 2. Here the dou by dou z is there. Dou by dou z. Take the z plus 1 and z plus 1 is a common here. In this, the z plus 1 whole power 4 is there. So it becomes of n into z power n minus 1 minus z power n into 2 whole divided by z plus 1 whole cube. Got it, my dear students? At z is equal to minus 2. So I take here the z plus 1. Here the z plus 1 is there, my dear student, because it is square is there. Z plus 1 is also there. Z plus 1 into n into z power n minus 1. Got it? So again, you can apply for this function. 1 by 2 into, I said 2 parts, dou by dou z of, I'm taking here. If this function, if I am taking, that it becomes of n into z power n minus 1 whole divided by z plus 1 whole square. The first part. The second part, the first one, minus, and here 2 into z power n only. 2 into z power n whole divided by z plus 1 whole cube. It is also dou by dou z, my dear students. Dou by dou z. At z is equal to minus 2 and both the functions. One is z power n minus 1 is already there. It is a z plus 1. It gets cancelled. So z1 plus 1 whole square only. Z power n minus 1 by z plus 1 whole square and 2 into z power n by z plus 1 whole cube. Okay. So I will take this function. I'm removing all these terms. See, first of all, if I am taking here dou by dou z of 1 by 2 already there. Dou by dou z of this function n into z plus 1 whole square, and for this function n minus 1 whole multiply with z power n minus 1 minus 1. Okay. According to the derivative of this, it decreases one value minus, and z power n minus 1 and apply the derivative of this v 2 into z plus 1 power 1 whole divided by z plus 1 whole power 4. Got it, my dear students? This is the first part. I am taking the first part here. In this, you can substitute the value of z is equal to minus 2. If I am taking here itself, this 1 by 2 is both the functions. If I am substituting the z is equal to minus 2 here, minus 2. So what is value? Minus 2 plus 1. So 1 by 2 into n whole multiply with z plus 1. Minus 2 plus 1 is a minus 1 whole square. N minus 1 and it becomes of minus 2 whole power n minus 2 minus 2 whole power n minus 1 2 into this becomes of minus 2 plus 1 is a minus 1 whole power 1 whole divided by minus 2 plus 1 minus 2 plus 1 minus 1 whole power 4. Okay, that is equal to, so leave it this 1 by 2 because it is both the terms is multiplied. Now I am writing only the n into minus 1 whole square. It becomes of a even term, the value is a positive only. N minus 1 and minus 2 whole power n minus 2 is there here. It becomes of a minus 2 whole power n minus 1 and minus 2 whole power minus 1. If I am writing the two parts, and minus 1 whole power 1, the value is a minus, and here the minus is there, it becomes of the plus 2 into minus 2 whole power n minus 1. Got it, my dear students? In these two functions, we have minus 2 power n minus 1 is a common term is there. Common term. Take that common term, minus 2 whole power n. Before that, it is a minus 2 whole power minus 1 is also there. So if I am writing here, it is a minus 2 whole power minus 1, and here the minus 2 whole power minus 1, it becomes of minus 2. Take here the minus 2 and removing here minus 1. Okay. And here also minus 2 whole power n, write as minus 2 whole power minus 1. I will take only the minus 2 whole power n is a common term. N into minus 2 whole power n is a common term. N minus 1 plus n minus 1, here the minus 2 whole power minus 2 means it becomes of 1 by minus 2 whole square. Nothing but it is a 1 by 4. Got it, my dear students? So 1 by 4 by, you can write as 1 by 4 is a 0.25. 0.25 is multiplied with the n minus 1 because it is a minus 2 whole power minus 2. I write it is a minus 1 by minus 2 whole square and 1 by 4 plus, I take only the minus 2 whole power n is a common term. It becomes of minus 2 whole power minus 1. So 1 by minus 2. That is becomes of 2 into minus 2 is get cancelled. And here the 2 is there and the minus 2 whole power n is becomes minus 2 whole power n. It takes the value is 1 by minus the 1 by minus 2. It becomes of minus 0.5. Minus 0.5. So erase this one and write it as a minus 0.5 and 2 into minus 0.5 into 2. It becomes of 2 into 0.5. Nothing but 1 by 2 is a 1. Value is 1. Got it, my students? N into 2 power minus 2 whole power n 0.25 into n minus 1. And again here also we can simplify this function. Simplify n into 0.25 minus 0.25 minus 1. It becomes of minus 1.25. That is equal to n into minus 2 whole power n. I will write here, my dear students, because the final step it is. I am not taking the 1 by 2 here. 1 by 2, keep it is a side. Only the inside function I got it is minus 2 whole power n minus 2 whole power n and n into inside it is a n minus 1.25 and minus. So I take that is as a 0.25 n minus 0.25 and minus 1. So minus 1.25. The final answer. Got it, my students. Now I will take the second function, dou by dou z of 2 into z power n by z plus 1 whole cube. Okay, it is multiplied with the first term is there 1 by 2 whole multiply. This is the first term. The first term, my dear students, here. And take the second term 2 into z power n by z plus 1 whole cube at z is equal to minus 2. Okay, I am doing this also. Now I am taking the second term 2 into already 1 by 2 is there. This 2 it get cancelled, it becomes of 1. Okay. So it is multiplied with the first term only 1 by 2. This 1 by 2, if I am taking only the 1 by 2 is multiplied with the first term. Now that 1 by 2 and 1 by 2 get cancelled, the dou by dou z of z power n whole divided by z plus 1 whole cube at z is equal to minus 2. So now we can apply the u by v rule. Take the z plus 1 whole cube and n into z power n minus 1 minus z power n and 3 into z plus 1 whole cube whole divided by z plus 1 whole power 6 at z is equal to minus 2. At z is equal to minus 2. Now I am substituting the z is equal to minus 2 in this equation. Minus 2 plus 1 is a minus 1 whole cube. N into minus 2 whole power n minus 1 minus minus 2 whole power n 3 minus 2 plus 1 whole cube, that is nothing but minus 1 whole cube, not the whole cube, my dear student. This is a square. This is a square only. Square, and it is also the square. Minus 1 whole square whole divided by minus 2 plus 1 whole power 6 is a minus 1 whole power 6. And it becomes of before that there is a minus is there, my dear students. For this function there is a minus is there. total function is minus is multiplied. Minus 1 whole power 6 is becomes a positive value. Minus of minus 1 whole cube, it becomes of minus n into, I take here that minus 2 is a whole power n, minus 2 whole power minus 1, and minus 2 whole power n, and 3 into, this is a square, is a value, is a positive value only, the 3, and divide by 1. This minus you can multiply the two functions, all it is a positive value it becomes. So take the common is a minus 2 whole power n as a common, and it having the n term is there, n minus 2 whole power n is becomes of n by minus 2 whole power minus 1. It becomes of 1 by 0.2, nothing but the 0.5, that too minus 0.5. And the minus into minus is becomes a plus. Minus 2 whole power is get the common, the 3. Now you can add this function to the first term. This is the second one we got. Second term. Add these two. Okay. And we have 1 by 2 minus 2 whole power n into 0.25 n and minus 1.25 plus this function, because I take already the minus here, I can add the term. Okay, what is our term here? The minus 2 whole power n, and it is multiplied with 1 minus 1 by 2. 1 by 2 is nothing but the 0.5, my dear students. So I take here the minus 2 whole power minus 1 is equal to, so 1 by minus 2. 1 by minus 2 means a minus 0.5. It is not the divide by the 0.5. Okay. I erase this function. It's minus 0.5. Write this as minus n into 0.5. Got it? So n 3 minus, I am writing the 3 minus n into 0.5. Got it? Again, in these two functions also, minus 2 whole power n is a common term is there. That is equal to minus 2 whole power n, you can take as a common. Minus 2 whole power n is to take the common, and whole multiply with the, I'm taking the n inside the 0.25 n square. I'm multiplying this minus 1.25 n and plus, and whole divided by 2 also there here, 2 and 3 minus 0.5 n, 0.5 n, the term. Got it, my dear students? That is equal to, this is only the second part we are doing, my dear students. The second part only. But the first part is already we got, it is a minus of n plus 3 minus 1 whole power n. We already got. And it is a minus 2 whole power. One thing, n square term is there. N square term 0.125 by 2. 0.125 by 2 is there. And it becomes of n square, and 1.25 by n, not the by n, 1.25 n by 2 is there. That is also the half part. and it is a n value. Got it, my dear students? So that is equal to, we can take it as a minus 2 whole power n minus 2 whole power n. What is a 0.25 divided by the 2? Half part is 0.125. 0.125. You can add the 0.125 onto 5, it becomes of a 0, and it is becomes of a 1 and 0.25, the half. Now I'm writing the 0.25 by 2 is a 0.125 n square. Got it? 1.25 by 2. 1.25 by 2 is a 2 times, and it is a 0.65. 0.65. 0.65 and the 0.5 here, because both are the negative values only. So 1.25 by 2. What is the value of 1.25 by 2? It becomes of 0.6 2 times, and another value is at the 5. 2 fourths, I think it is a 4. Okay, or in terms of, you can take it as a value is a 5, 0.5 and 0.65. 0.64, let it be take, it is a 5, 0, let with the 4, and it is becomes of 6 by 5, it is 1, and it becomes of 1.14. 1.14. Finally, we can write as a 1.25 exact value, and 0.5 here. Exactly, you can take it is 1.25 you get. So if I am taking 125, half value is 62.5. Exactly, if I am writing 0.625, and it is a 5.5, you can add 5, 2, and it is becomes of 1.125. You can write as a 1.2. Let be the what it matters, students. So this, if I am writing, is a point minus 1.25, not the 1.25 n, and the last value here we have only the 3 plus 3. What it? So this is a function what we have. Minus 2 whole power n, 0.25 n square, minus 1.25 n, 1.125, my dear students. It is not whatever we got, it is a 1.125. This is wrong here we got. This what we got, it is a 0.625 and the 0.5. What is the value? 5, 2, 1 and 1.2, 1.125 only. Okay. This is not the 1.25. Modify this 1.125 n. I also wrote here the wrong. Minus 1.125 n. This is the final answer we got, and you can add this function with the previously what we got. It is the first part, minus of n plus 3 minus 1 whole power n v of n. Got it? So these are two parts we got. Why I multiplied is a 1 for the first ROC, saying that greater than the 2 and less than the 1, less than the 1, less than the 1, x of n is equal to, you see, instead of mu of n, write this mu of minus n minus 1, keep the minus in front. Mu of minus n minus 1, keep the minus in front, and mu of n minus 1, keep the minus is in front. Okay, both will get it is a 1 minus into minus is a plus here, and here the minus into minus, it is not the minus minus, it is the plus. This value is already we have is a plus, and inside there is a minus 2 whole power n. Modify this also. So first term is a plus and the second term is a minus. In between 1 less than the z and the less than the 2 means z is greater than the 1 and z is less than the 2. So greater than you can multiply with the mu of n without keeping the minus here. And less than means before that you can keep the minus and becomes is a minus mu of minus n minus 1. Wherever the value is 1, write is a right hand side. Wherever the value is a 2 is there, you can write in the left hand side. Got it, my dear friends? See here. 1 with mu of n and 2 with mu of minus n minus 1. And here also within the bracket I wrote 1 with minus of mu of minus n minus 1 and 2 with minus of mu of minus n minus 1. And here within the bracket I wrote one first term is multiplied with the mu of n and second term is multiplied with the mu of n. Got it, my dear students? Is here the 1.125. 1.125. This is a modified, my dear student. 1.125. And this is also 1. Got it? Then you go for the next one. Convolution method. Convolution method. This is the last method in the inverse transformation. First one is a power series method. Second one is a partial differentiation method. And third one is residue method. And the last is a fourth method is convolution method. We know the convolution of time domain is a product of the frequency domain, nothing but z domain here. Take the one example. One example here, z square by z minus 2 and z minus 3. I modify this x of z is z by z minus 2 and z by z minus 3. Take one function is x1 of z and second function is x2 of z. Okay. And you can find the inverse transformation with z is greater than the 3. Z is greater than the 3. Greater than means irrespective of the value, you can write it is in the right hand side only. The first one, x1 of z, z by z minus 2 means 2 power n mu of n. Why? Because it is a greater than. And x2 of n is a 3 power n mu of n. Z by z minus a is nothing but a power n mu of n. We got the two functions in the time domain. What is the convolution? X1 of n and the x2 of n. Find out using the formula 2 power n mu of n with the convolution of 3 power n mu of n. What is the formula here? Sum of k equal to 0 to n. Actually minus infinite to infinite. Why I am taking the 0 to n? Because it is a multiplied with the mu of n is there. Okay. According to the function x1 of n with the convolution of x2 of n, the formula is sum of k equal to minus infinite to infinite, x1 of k, x2 of n minus k. This is a formula for the convolution of discrete time function. So sum of k equal to minus infinite to infinite. What is the first one? X1 of n is in terms, now the change is as a k. 2 power k mu of k. In this 2 power n mu of n, now it is I am changing the variable as a k, and x2 of n, 3 power n mu of n. So I write it as a 3 power n minus k because the k instead of k there is n minus k, mu of n minus k. What it matters? We know the mu of k is equal to 1 for k is greater than or equal to 0, and mu of n minus k is also 1 for n minus k is greater than or equal to 0, and n minus n is greater than or equal to k. N is greater than or equal to k, or k is less than or equal to n. Now k is greater than or equal to 0 and k is less than or equal to n means within this range there is a 0 to n. Now I am changing this as a sum of k equal to 0 to n only, because less than or equal to n. The intersection range, the 2 power k, and 3 power n minus k. And the two functions mu of k and mu of n minus k, the value is a 1. And here the summation is a k, taking only the k values. Power n is a constant, 3 power n if I am writing. The sum of k equal to 0 to n, 2 power k, 3 power minus k. And again, you can write the 3 power n, and becomes the value is a 3 power k and 3 power minus k. Here both the bases are not the same. Both the bases are not same functions. Got it, my dear students? So now I am writing the sum of k equal to 0 to n, the 2 power k and 3 power k, because it is the inverse. That is equal to 3 power n into sum of k equal to 0 to n, 2 by 3 whole power k. Now use the formula, sum of n is equal to n1 to n2 e power n. You know the formula is there. That is 3 power n into whole multiple. K is equal to 0, means that 2 power 3 whole power 0 minus 2 power 3 n2. n2 is nothing but n, n2 plus 1 whole divided by 1 minus a, 2 by 3. What divided students? So 3 power n into anything power 0 is a 1, and 2 by 3 whole power n plus 1 and whole divided by, and this value denominator is a 3 minus 2. Take the 3 minus 2 is a 1, 1 by 3, 1 by 3, and it becomes of numerator 1 by 3, and it is a 3 power 1 only. Finally, you can write this function as a 3 power n plus 1 whole multiply with 1 minus 2 by 3 whole power n plus 1. The x of n is equal to, by using the convolution formula. Using this convolution property, first of all, you can divide the given equation into two parts. One is x1 of z and the x2 of z. Write the time domain function according to the formula, standard formulas, and apply in the, substitute in the convolution formula and simplify. You'll get the 3 power n plus 1 into 1 minus 2 by 3 n plus 1. Got it, my dear friends? This is the same thing we got 3 power n plus 1, 1 minus 2 by 3 n plus 1. Because it is a greater than, you can multiply with the mu of n and the mu of n. Both the functions. And you see here the 3 power n plus 1 and multiply the 3 power n plus 1 in the denominator get cancelled. 2 power n plus 1 into mu of n. And another example we have here, z by z minus 1 and z minus 1 by 2. Take the function as a z by z minus 1 as a x1 of z and 1 by z minus 1 by 2. And x1 of n, 1 power whole power n mu of n minus, and this value is mu of n. x2 of n is only it is not in the form of z by z minus a. When it is a z by z minus a, then only we have a power n mu of n. But 1 by z minus a, inverse z transformation is 1 by 2 whole power n minus 1 mu of n minus 1. One sample is shifted towards the right side. Z by z minus a value. What it minus friends? 1 by 2 whole power n minus 1 mu of n minus 1. One sample. So a power n minus 1 mu of n minus 1 is a z by 1 by z minus a. Remember this one. This is also the standard function. A power n minus 1 mu of n minus 1 is 1 by z minus a. So we get the 1 power n mu of n for the first one, and second one is 1 by 2 whole power n minus 1 mu of n minus 1. And using this convolution formula, the substitute 1 by 2, the mu of k, I'll explain. The sum of k equal to minus infinite to infinite, x1 of n, x1 of k, x2 of n minus k. What is the x1 of k? We got 1 whole power n mu of n. Sum of k equal to minus infinite to infinite, 1 whole power k mu of k, and second function is 1 by 2 whole power n minus 1. Actually, it is a n minus 1. Instead of n minus 1, n is changes as n minus k minus 1. And mu of n minus k minus 1. What it matters to us. So mu of k is equal to 1 for k is greater than or equal to 0. And mu of n minus k minus 1 is equal to 1 for n minus k minus 1 is greater than or equal to 0. Got it, my dear friends? So n is greater than or equal to k plus 1. Okay. For n minus 1 is greater than or equal to k, and k is less than or equal to n minus 1. So using these two relations, you can write the summation is the sum of k equal to 0 to n minus 1, 1 power k, anything power 1 is a 1 only, 1 by 2 whole power n, and another one is there 1 by 2 whole power minus of k plus 1, minus of k plus 1. That is equal to sum of k equal to minus 0 to n minus 1. 1 by 2 is a common term here, 1 by 2 whole power n. And here it is there, the 1 by 2 whole power minus k. So if I am writing this function as 1 by 2 whole power minus 1 whole power k, and 1 by 2 whole power minus 1. Got it, my dear students? It is in the form of 1 by 2 whole power minus 1. Or in the form of, you can say the 2 power minus 1, the 2 power k it is. 2 power k. 1 by 2 whole power minus 1 is already there here. 1 by 2 whole power minus 1. And here the 1 by 2 whole power again. Take these as a totally the common. 1 by 2 whole power n minus 1. And it becomes of sum of k equal to 0 to n minus 1. Now 1 by 2 whole power minus 1 is nothing but 2. 2 power k. 2 power k. Now it is in the form of sum of n is equal to n1 to n2 a power n. What is the formula? We got 1 by 2 whole power n minus 1 whole multiply with a power n. So 2 power 0 because it is a n1 is a 0, and 2 power n2 plus 1. n2 plus 1. n2 is n minus 1 plus 1, and whole divided by 1 minus 2. So 1 by 2 whole power n minus 1 whole multiply with 2 power 0 is a 1 minus 2 power, and this is becomes get cancelled, 2 power n whole divided by minus 1. Minus 1. Got it, my dear students? So now if I am taking power n minus 1, take this minus, you can multiply 2 power n minus 1. 2 power n minus 1. What is the final answer? We got 1 by 2 whole power n minus 1. Here I am taking 1 by 2 whole power n minus 1, 1 minus 2 power n. Simplify this one. So 1 minus 1 by 2 whole power n minus 1, and because it is a 1 minus, if I am taking the plus value, simplify it is a 2 minus 2 into 1 by 2 whole power n mu of n. Okay, into mu of n. Why it is a mu of n? It's mu of n because it is a positive value they are asking. Then it becomes of mu of n. Okay, why it is a mu minus is there? 1 minus 2, it becomes a minus here. If I multiply this as 1 by 2 whole power n minus 1, the 2 power n minus 1 minus 2. So 1 by 2 whole power n and the 2 power n. It becomes of 2 power minus n into 2 power n minus 1. So I'm writing the 1 by 2 as a 2 power minus 1. Multiply this function 2 power minus 1 and the 2 power n becomes of the 2 power 0 value. N minus 1 minus 2. So it is not the n minus 1. Okay, now we can multiply 2 power n minus 1 is a plus minus of n minus 1. It is multiplied with the 2 power n and minus 2 power minus of n minus 1. Okay. And now it becomes of 2 power minus n plus 1 and the 2 only. The first term becomes a 2. And second term is minus 2 power minus n and 2 power plus. That is equal to 2 into 2 you can multiply 1 minus 2 power n into mu of n. Is only they write it is a 2 power minus n is a 1 by 2. So 2 minus 2 into 1 by 2 whole power n mu of n. Otherwise, this becomes of 2 you can take as a common. 1 minus 1 by 2 whole power n mu of n. Got it, my dear students? Mu of n. So using this convolution method, you can find out the inverse transformation. So we find the power series or the long division method, and second one is a partial fraction expansion method, and third one is a residue method, and the last it is a convolution method. Okay, and the next one is a linear time invariant system. To find the linear time invariant system, system stability and the causality, and this we can discuss in the next class, my dear students. Whatever we have the linear time invariant system, that we'll discuss to find the inverse transformation, or for any given the linear time invariant system, how we can find the Z transformation and how we can find the inverse transformation. That we'll discuss in the next class, my dear students. Got it? Any doubts? Thank you.